Welcome to the DIY Honda Garage channel. The DTC P2073 refers to a situation where the manifold absolute pressure (MAP) sensor signal is higher than what the vehicle's engine control unit (ECU) anticipates. This code indicates potential issues with the MAP sensor's reading, which is crucial for the vehicle's air-fuel ratio and overall performance. The MAP sensor measures the pressure inside the intake manifold, allowing the ECU to adjust fuel injection and ignition timing accordingly. A faulty MAP sensor can lead to poor engine performance, higher emissions, and reduced fuel efficiency. It is located on the intake manifold in the engine bay, so accessibility for inspection or replacement is generally good. Before diving into troubleshooting, it's important to check for any poor connections or blockages in the intake air duct that might lead to misleading sensor readings. The DTC P2073 indicates that the MAP sensor is delivering a signal that suggests a higher pressure than expected. The key component affected in this scenario is the MAP sensor itself, which plays a vital role in determining the air pressure in the intake manifold. This information is essential for the ECU to optimize fuel delivery and ignition timing. The MAP sensor is typically located on the intake manifold, which is part of the engine's air intake system. Inside the intake manifold, it ensures that any changes in air pressure are communicated to the ECU in real time. It is important to note that this code falls under the Powertrain Control Module Fuel Injection PGM-FI system. Understanding the layout of components in this area is essential for effective troubleshooting. In diagnosing the P2073 error code, various possible causes must be considered. Firstly, vacuum leaks in components such as the PCV valve or the intake manifold can dramatically affect pressure readings. These leaks allow unmeasured air to enter the manifold, skewing the MAP sensor's output. Secondly, the MAP sensor itself might be faulty, which is a common issue that can arise due to wear or damage over time. Additionally, poor electrical connections, either at the MAP sensor or other related components, could lead to erroneous readings, as broken or corroded wires can disrupt the signal being sent to the ECU. Each of these factors can contribute to the MAP sensor delivering a higher than expected signal, which leads to the P2073 code being triggered. The symptoms associated with DTC P2073 can significantly affect vehicle performance and drivability. One of the primary signs is poor engine performance, which may manifest as hesitation or stalling during acceleration. This occurs because the ECU is unable to accurately adjust the fuel-air mixture due to incorrect MAP sensor data. Increased fuel consumption can also occur since the engine management system may enrich the fuel mixture inappropriately, leading to wastage. Additionally, drivers may notice that the DTC indicator light on the dashboard remains illuminated, indicating an ongoing problem that needs to be addressed. These symptoms underline the importance of promptly diagnosing and rectifying any issues associated with this DTC. The first step in troubleshooting DTC P2073 involves checking for vacuum leaks, as these can significantly impact the MAP sensor's functionality. Equipment like smoke machines or soapy water can help identify any leaks in critical areas such as the positive crankcase ventilation PCV valve, PCV hose, EVAT purge valve, throttle body, and the intake manifold. These components play vital roles where any leaks could allow unaccounted air to affect pressure readings. The brake booster line should also be inspected, as leaks here can interfere with engine performance. If any vacuum leaks are detected, the responsible components must be repaired or replaced. If no leaks are found, the troubleshooting can proceed to the next step. In this second step of troubleshooting, begin by starting the engine and holding it at a stable speed of 3,000 RPM without any load until the radiator fan activates. This is crucial for ensuring that the engine reaches optimal operating conditions for testing. Using the Honda Diagnostic System, HDS, monitor the map sensor's output parameters over a 5-second period. For models from 2016, the readings should not drop below 36.9 kilopascal or 277.0 millimeters Hg, while from 2017 to 2022, the thresholds are 48.0 kilopascal or 360.0 millimeters Hg. If the map sensor accurately maintains these values over the required time, move on to evaluate the current condition. If readings are consistent with malfunctioning thresholds, the map sensor should be replaced as per diagnostic guidelines. The final troubleshooting step requires clearing the DTC using the HDS to reset any stored codes. This process is essential for conducting a valid test drive to confirm whether the issue persists. During the test drive, maintain engine coolant temperature above 158 degrees Fahrenheit, 70 Celsius, and keep engine speeds within the range of 1,400 to 5,300 RPM. Drive the vehicle steadily at speeds between 55 and 75 miles per hour, 90 to 120 kilometers per hour, for at least 10 seconds before allowing the vehicle to decelerate with a closed throttle for over 2 seconds. Following the test drive, check the onboard diagnostics (OBD) status for any reoccurrence of DTC P2073. If the HDS indicates a failure, it confirms that the map sensor needs replacement. However, if it indicates a pass or intermittent failure, perform a further investigation of electrical connections and wiring to ascertain their integrity. After completing the necessary repairs or component replacements related to DTC P2073, it is vital to verify that the original issue has been successfully resolved. This verification process involves ensuring that no DTC is present in the HDS after clearing the codes. Once confirmed, a thorough test drive should be conducted under a variety of driving conditions to validate the repairs. The vehicle's performance should improve, and symptoms such as the check engine light remaining illuminated should cease. Monitoring the OBD system during the drive will also help ascertain that the map sensor is functioning optimally. If no further codes appear, it confirms a successful diagnosis and resolution. To avoid issues associated with DTC P2073 in the future, implementing a preventive maintenance routine is essential. Regular inspections of vacuum hoses can preemptively identify wear and tear, which may lead to leaks affecting the map sensor's readings. Checking electrical connections ensures that they remain free of corrosion and secure, reducing the risk of erroneous signals being sent. It is also advisable to monitor the longevity and performance of the map sensor regularly, as it is a critical component in engine management. By conducting these preventive checks, vehicle owners can maintain optimal performance and greatly minimize the chances of encountering the DTC P2073 again. In summary, DTC P2073 signifies an alarming situation where the map sensor signal exceeds expected values. This code encapsulates a series of troubleshooting steps, from checking for vacuum leaks to performing sensor performance tests and verifying repairs. Understanding the map sensor's vital function in monitoring air pressure provides insight into why accurate readings are crucial for optimal engine performance. The outlined diagnostic and preventative measures equip technicians and owners alike to address issues promptly and effectively, enhancing vehicle reliability and efficiency. Proper troubleshooting ensures that underlying issues are fixed rather than just addressing symptoms, leading to a better driving experience and prolonging engine health. Please like and subscribe to the channel. See you next time.